Hello, fifth grade. It's Wednesday, the 28th of May, 2020, and it is time for our science. We are on page 227. We're going to learn about different forms of precipitation. This section will be a little more familiar to you than the other things that we've been learning, which are pretty vast, means kind of there's a lot of moving parts and can be kind of complicated. So this is something that you might be more familiar with, because precipitation is anything that falls from the sky: rain, snow, sleet, hail. Now, we don't experience sleet or snow or hail that often, but you maybe you've been to the snow before. I hope it's pretty fun. Maybe you've been around when it's snowing. You'll know what wet snow feels like, what dry snow, powdery snow feels like. Maybe some of you ski. Maybe you have grandparents or family members that live in a place where the seasons change more dramatically than in LA. And you've definitely seen it on TVs, movies, read about it in books, etc. So we're going to talk about that. So it's called 8.5, Water from Above, a Gift from God. I'm on page 227. Just previewing our comp check. Pretty simple. It says describe how each type of precipitation is formed. A, how is dry snow formed? B, how is ordinary rain formed? C, how is sleet formed? D, how is tropical rain formed? E, how is freezing rain formed? And F, how is wet snow formed? And number 2, are all snowflakes different? Okay, so we're going to learn about that. So it says you can spend many enjoyable hours watching the never-ending variety of shapes in the clouds. We talked about that yesterday. Their white brilliance against the deep blue of the sky is a strikingly beautiful sight, although one we often take for granted in our everyday lives. The flaming reds and oranges and the delicate pinks and purples of the clouds at sunrise and sunset are an awe-inspiring example of God's artistic talents displayed in creation. But as fascinating and beautiful as the clouds are, God did not place them in the sky just so we could look at them. God designed clouds to be the instruments he uses to water the earth. Without clouds, all the lands of the world would become drier than the dustiest desert. Clouds and their life-giving waters are a gift from God. Okay, so clouds aren't just there, in other words, to be pretty against the blue sky. But they serve a purpose, and we know that we can't live without water, and they are what brings water to our earth. So they are a gift from God. They also described a sunset. We've all encountered beautiful sunsets, and so God is amazing. So you look at those pictures there. It says Amos 5:8, seek him that calleth for the waters of the sea and poureth them out upon the face of the earth. The Lord is his name. So Amos is a book in the Bible, and it's talking about how he sent waters to the earth. And that is what gives us life. And so we need to seek that source of life for us. What goes up must come down. Through evaporation and the action of rising air, water vapor is lifted far above the earth's surface to form clouds. The water droplets or ice crystals that make up clouds are so light that they stay suspended in the air without falling. Let's turn the page. What then causes rain or snow or ice to drop out of the clouds? So evaporation takes them up to the clouds and it forms a cloud. We've talked about that before. But what keeps those from crashing down to the earth and keep the rain inside, or the sleet or the hail or the snow? How does the water stored in clouds get back down to the earth? Whether it takes the form of rain, snow, or ice, water that falls out of clouds is called precipitation. Most forms of precipitation start out as ice crystals in the tops of clouds. These clouds' tops are very high in the air, even where temperatures stay far below freezing, even on the warmest summer day. In these cold regions, the clouds are made up of both ice crystals and water droplets. The crystals and the droplets are very tiny to start with, but the cold temperatures cause the ice crystals to grow bigger by taking moisture from the surrounding droplets. Soon the crystals become too large and heavy to be held up by the air, and they begin to fall through the cloud on their way to the ground. Okay, so I want to read that one more time so you can understand precipitation. This is review. Basically, we talked about this before, but let's really understand this. So it says most forms of precipitation start out as ice crystals in the tops of clouds. These cloud tops are very high in the air, where temperatures stay far below freezing. We talked about that uppermost part of the troposphere. And I get freezing even on the warmest summer day. Okay, so the closer you are to the top level of that troposphere, no matter how warm it is, closer to the surface of the earth, it's always below freezing. It says far below freezing. In these cold regions, the clouds are made up of both ice crystals and water droplets. The crystals and the droplets are very tiny to start with, but the cold temperatures cause the ice crystals to grow bigger and bigger by taking moisture from the surrounding droplets. Soon the crystals become too large and heavy to be held up by the air, and they begin to fall through the cloud on their way to the ground. Okay, so as that combination takes place of, it talked about those ice crystals and those droplets of water get heavier and heavier and fuller and fuller and fuller, they're going to come crashing down to the earth through rain. Precipitate or snow or sleet or hail. Precipitation personalities. Precipitation arrives on the ground in many different forms. The various types of precipitation develop their unique characteristics or personalities as they travel through the air down to the earth. Rain, the ordinary drip. An ordinary raindrop starts out as an ice crystal in the top of a cloud. When the crystal grows too heavy to float through the air anymore, it falls out of the cloud. During its journey to the ground, the ice crystal runs into warmer air and it melts. Melting ice becomes water. Soon afterward, it strikes the earth as a drop of liquid water. Okay, that's ordinary rain. Wet snow, friends who stick together. Snow falls when the temperature of the air at lower levels is cold enough to keep the ice crystals from melting into rain on their trip down to the ground. So if it's warmer, they're ice crystals at the top. As they start falling down, if the air is warmer, they will melt. If the air remains cold, they will stay solid. Okay, so ice crystals form into wet snow when the temperature of the air they pass through is right at or just above the freezing point of water. So 32 degrees Fahrenheit, 0 degrees Celsius. Right at that point or around that point of degrees. Under these conditions, falling ice crystals melt only slightly and then stick and freeze together to form large clumps called snowflakes. The snowflakes are so sticky that they cling to every surface they land on, creating the kind of spectacular snowscape in which even the tiniest branches and twigs are outlined in white. You see this picture here. So this is wet snow. It sticks to it. Okay? Wet snow is called good packing snow. You can make a snowball from that because it makes the best snowballs and snowmen. So again, wet snow, ice crystals on the top. It falls down. As it's falling down, the temperature is about freezing, around freezing, so it still stays somewhat frozen, but it's warm enough to melt it just a little bit so that it sticks to the other snowflakes around it. Okay, it sticks to those other ice crystals, and therefore it comes down a little wetter. Think about it like a slushie. Okay, you can pack it a little bit for a good snowball. So it's got a little moisture to it because as it falls, the temperature is a little warmer than freezing, so it melts it a bit, and that causes it to stick together. Okay, dry snow is the opposite. Dry snow, solitary travelers. Dry snow falls when the temperature of the air is well below freezing. Ice crystals falling through very cold air do not melt and stick together to form large wet snowflakes. They don't do that, but travel singly to the earth. Okay, one at a time. Because the individual crystals do not cling to each other, dry snow is very loose and powdery, making it the best kind of snow for tobogganing and skiing. This sort of snow is also easily blown into tall snowdrifts by the wind. So you could see that powder? It comes up. I've been in powder snow before. For the life of you, you can't make a snowball. And when you live in LA and it's a big deal to make a snowman or have a snowball fight, you know, I've only been in snow a handful of times in my life, not very many, probably 10 or under. the time I've experienced dry snow, it was like a bummer. I mean, it's fun to throw up, to just throw up in the air, but you can't really pack a snowball or make a snowman. It doesn't stick together at all. But it's great for skiing. Skiers love powder. So you can see this picture here, formation and precipitation. Tropical rain, we see it's hot, so it's wet, and you'll get bigger raindrops, you get more rainfall. Here is just ordinary rain. You see how it's less water. We talked about the ice crystals falling, meets the warmer water, melts, but this is like really hot, tropical. Okay, we've talked about that before, the equator. Freezing rain, we see, we're gonna talk about that. Sleet, we're gonna talk about that too. Dry snow, we talked about that. Well below freezing, stays freezing, freezing, is powdery because it doesn't stick. There's nothing that melts it a little bit so that it will stick together. And wet snow, you could see cold. The blue is a cold, then it gets a little warmer, melts a little bit, and the dried snow sticks together because the temperature is a little warmer. So it becomes wet snow. Those individual particles stick because it melts just a little bit. It's just on or around freezing. Okay, so you can look back at that picture to see it starts at the uppermost part of the cloud where there are ice crystals. You see the blue arrows. Sometimes they'll meet with the orange arrows, which indicates warmer temperatures, and then you'll see how it falls. All right, so let's read on. Ice, the quick change artist. Usually air near the Earth's surface is warmer than the air higher up in the troposphere. We know that. Colder, higher the colder we get. But sometimes a layer of warm air will rise over the top of a layer of cool air. If the temperature of the warmer air is above freezing and the temperature of the cooler air is below freezing, the conditions are just right for two different kinds of icy precipitation to form. So you're going to see sleet is a form of, and freezing rain, that's a form of ice, okay? So I want to read that again. Usually air near the Earth's surface is warmer, we know that, than the air higher up near the troposphere. But sometimes a layer of warm air will rise over the top of a layer of cold air. So here's cold air, warm air will rise up above it, okay? If the temperature of the warmer air is above freezing and the temperature of the cooler air is below freezing, the conditions are just right for two different kinds of icy precipitation to form. Okay, so ice crystals falling through the warmer air melt and turn into raindrops. Ice crystals, we know that, falling through the warmer air, melt and turn into raindrops. But when they strike the layer of colder air, they may refreeze and turn into tiny pieces of ice, forming an unpleasant kind of precipitation known as sleet. If they do not refreeze in midair but continue all the way to the ground as a liquid, the cold raindrops freeze as soon as they land, forming a coating of ice on every exposed object. Okay? So if you look at your example of sleet, we see right here, we see cold, okay? Higher, it warms up again, but then it stays warm a little bit, but then the temperature, wherever you are, goes below freezing again, so it's frozen, it warms up, becomes rain, then closer to the earth, it freezes again because of the temperature, so it's like it refreezes, and then it will blanket everything in ice, okay? Everything in ice, making it dangerous to walk. I remember my aunt was walking, and she was on Marky's mom, and she was walking on sleet. The ground had just frozen over, and there's just a layer of ice, and she slipped and broke her wrist really badly. I remember that. Keep praying for Marky. He's doing okay. Appreciate that. So that's an example of sleet right here. Freezing rain, same kind of thing, refreezes sleet again, same kind of thing. We see sleet there. Okay. It says, if they do not refreeze in midair but continue all the way to the ground as a liquid, and then they hit that freezing ground, they'll freeze, okay? And that forms a coating of ice on every exposed object. This type of precipitation is called freezing rain. Although the icy coating on trees, houses, and telephone lines is a breathtaking sight, it's really cool to look at, especially for those of us who aren't used to it. Freezing rain causes much damage to plants and buildings and makes roads extremely slippery and dangerous, like the sidewalk where my aunt slipped. So there's a picture of freezing rain. Look at that. It literally froze in midair. Okay, it makes you think of the movie Frozen. Literally froze. You could see the droplet froze in midair. Tropical rain, going along with the crowd. A tropical raindrop may be the only type of precipitation that does not begin its life as an ice crystal. In the tropics, near the equator, the temperature of the air at the level where rain clouds form is not below the freezing point of water, so it doesn't start out as ice crystals in that regard. Because no ice crystals can exist in these clouds, rain must form by a different method. Water vapor condenses on large particles of sea salt in the air. A water droplet around one of these particles may easily become heavy enough to begin falling through the cloud. As it falls, it crashes into smaller water droplets that lie in its path. Some droplets bounce away, but others are irresistibly swept up into the bulk of the big droplet. By absorbing many of these tiny droplets, the big water droplet grows into a full-size raindrop as it falls out of the cloud on its way to the earth. So again, tropical rain. Look at the size of that raindrop compared to an ordinary. Okay, it starts out warm. As it crashes into smaller water droplets, it says it could grab them and therefore be a huge water droplet. So one water droplet can be huge in a tropical rainstorm, not like little sprinkles that we get here and there. Okay, they're huge. And so you can see the visual here, the difference between, this is one raindrop. This is symbolizing one raindrop. And this is with ordinary rain. So you can see that's like doubled the size of ordinary rain. And it's because it catches other water droplets on the way down, falling from the cloud. So I want you to look really quickly at investigating snow crystals. Okay. It says, I'm looking at this. If you live in a part of the world where snow falls, you have probably spent many hours packing snow into snowballs, sculpting it into snowmen, or even shoveling it off your sidewalk. You may enjoy winter activities such as sledding, skiing, or snowmobiling. But have you ever taken the time to look closely at a snow crystal? These tiny works of art are so complex in their structure that no two identical crystals have ever been formed. Okay, so we had a question, number 2. It says, are all snowflakes different? Yes, it says right there. And that's just God. Just like no two fingerprints are alike of all the big billions of people that have lived since the beginning of time, if not trillions, no two fingerprints are alike. Okay, it says the best snow crystal specimens are those that you can catch while they are still in the air before they reach the ground. In order to view the crystals, you will need a square piece of black cloth about the size of the palm of your hand and a magnifying glass. Look at the pictures. Now, we're not near snow, so the best we can do is look at the picture here. And you can see these are just different types of snowflakes. The needle, the column, the plate, the column capped with plates, the dendrite, the star. Okay, so if you've got a piece of black fabric, here's my charger. Whoops, sorry, my phone charger. Imagine, oh, hang on, I can't use that because it's attached to the phone. Forgive me for that, guys. So imagine if I had a piece of black cloth. My shirt's like a dark blue, and I had it in my hand, and I try to catch those snowflakes. I could see whether it's a needle or a column or a plate, or a column capped with plates, or a dendrite, or a star. Okay, it says, prepare the cloth by getting it wet and then placing it flat in the freezer. When the cloth is frozen hard, you are ready to go snow crystal hunting. The next time it snows, as the crystals fall through the air, capture some on your cloth and observe their design through the magnifying glass. What shape do the snow crystals have? Remember that when the temperature is near freezing, snow crystals clump together into large snowflakes. Okay, it's wet snow. Although each snow crystal has its own individual shape, it can usually be placed into one of these groups. Again, the needles, columns, plates, columns capped with plates, dendrites, and stars. Okay, I wanted to see some really quick. All right, so that's, I mean, we can't do that, but we can look at these pictures and check that out. That's pretty cool. All right, so again, your comp check, describe each type of how each type of precipitation is formed: dry snow, ordinary rain, sleet, tropical rain, freezing rain, wet snow. And number 2, are all snowflakes different? All right, do a good job.